Welcome to this explainer. You know that feeling when you're staring at a screen full of tangled, messy code? The kind that just breaks the second you try to add one tiny new feature? Yeah, we've all been there. It's frustrating, it's a massive time sink, and it just piles on the technical debt. Well, today, we're going to transform that coding chaos into some seriously elegant architecture. We are diving into the heavy-hitting toolkit that professional developers use to solve those exact same problems, efficiently and elegantly. We're talking about design patterns. So ask yourself, is your code missing a blueprint? Because honestly, without a solid plan, software design turns into a massive, tangled mess real fast. Think about building a house. If you don't have a blueprint before you start, you're just haphazardly stacking bricks, running wires wherever, and basically crossing your fingers that the roof doesn't cave in on you. Software is literally the same way. Without underlying structure, it'll just collapse under its own weight. And that leads us right into our core analogy for today. Section 1. The recipe versus the blueprint.
Okay, let's dive right into this. To really get what a design pattern is, it helps to compare it to something we're all super familiar with, an algorithm. Now, an algorithm is basically a baking recipe. It gives you clear, fixed, exact steps to reach a highly specific goal. You add 2 eggs, mix for 5 minutes, bake at 350 for half an hour, boom, cake. It's a strict step-by-step. But a design pattern, that's more like a blueprint. It's a high-level, super flexible description of a solution. A blueprint tells you, hey, this house needs a solid foundation and load-bearing walls, but the exact order you build it in or what specific wood you buy, that is entirely up to you and the specific realities of your project.
So the key takeaway here is that a design pattern is a typical solution to a common problem. It is highly conceptual. You can't just find a pattern online, copy it, and lazily paste it into your code base like you would with a standard library function. It just doesn't work that way. Instead, you study the pattern's core idea, and then you write a customized solution that actually fits your specific program. In fact, if 2 different developers use the exact same pattern to solve the exact same problem, their final code will probably look totally different because they adapted that blueprint to fit their unique constraints. Moving on to Section 2, Anatomy of a Pattern. Because these patterns are such high-level abstract concepts, they need to be described very formally so developers can actually reproduce them across totally different contexts. Reading a pattern is kind of like reading the legend on a map. It systematically guides you. First up, you have the intent. This just briefly outlines the problem and the proposed solution. Then comes the motivation, which goes a bit deeper into why this specific solution actually makes things better. Third is the structure. This visually breaks down the classes, showing you how all the different moving parts interact with each other. And finally, number 4, a code example. This gives you a real-world implementation in a popular language just to help bridge that gap from pure concept to actual working reality.
Section 3, from buildings to code.
Now, where do you think all this originated? You'd probably guess some high-tech computer science lab, right? Actually, it's a crazy leap from physical, real-world architecture straight into digital software. Back in the 1970s, an actual physical architect named Christopher Alexander wrote a book about a pattern language for urban design. He was literally dictating stuff like window heights and green space sizes to maximize human comfort. Fast forward to 1994, and 4 authors realized, wait a minute, this blueprint idea works perfectly for programming. They dropped a legendary bestseller outlining 23 object-oriented programming patterns. They got so famous, they're now just called the Gang of 4, or GOF. And from that one book in 94, dozens of other patterns have popped up. And today, they're used across literally every programming field imaginable.
Section 4, learning the shared language. So I know some of you might be thinking, look, I've coded for years without knowing any of these official names. Why bother now? Well, put yourself in a busy team environment. Say you're wrestling with some object creation issue, tearing your hair out. A teammate walks by and just casually says, oh, just use a singleton for that. A singleton, by the way, just ensures a class only has one instance running at a time. But here's the genius part. They didn't have to grab a marker and spend 30 minutes drawing diagrams on a whiteboard. With just one word, everyone instantly gets the entire underlying logic. It creates this hyper-efficient, universally shared language that saves countless hours of painful back-and-forth communication.
Which brings us to Section 5, the Golden Hammer Trap. To make this a fully well-rounded explainer, we definitely need to acknowledge the critics. Let's neutrally look at the arguments against using design patterns. First off, some argue they're often just kludges, basically band-aids for weak programming languages that lack proper abstraction. For instance, some complex patterns meant to encapsulate behavior, like the strategy pattern, can actually be swapped out for a simple one-line anonymous lambda function in most modern languages. Critics also point out that patterns can lead to highly inefficient, dogmatic code if developers treat them like rigid gospel rather than adapting them. And finally, there's the whole issue of enthusiastic novices using them when they totally aren't justified.
Which tees up this classic proverb perfectly. If all you have is a hammer, everything looks like a nail. This is absolutely the ultimate trap for newer developers. Once they learn about these cool new blueprints, they get so excited that they try to force complex patterns into literally everything, even when a few lines of basic code would work perfectly fine. They over-engineer it just out of sheer excitement. So consider this a friendly but serious warning. Please don't overcomplicate your code base just to flex that you know a design pattern. Let the problem dictate the solution, not the other way around.
Section 6. Constructing the architecture. All right, let's see how all this builds together. With dozens of patterns floating around out there, how do developers actually organize this massive toolkit? Well, patterns differ vastly by scale. On the low end, you've got idioms. These are basic, low-level patterns, usually tied to just one specific programming language. An idiom is kind of like installing a simple traffic light to make one specific neighborhood intersection safer. It does one exact job, really well. On the complete opposite end, you have architectural patterns. These are massive, universal, and dictate the structure of your entire application. That's more like designing a sprawling, multi-level highway interchange with underground passages to handle tens of thousands of cars a day. Beyond just the scale, developers also group them by their core intent. This breaks the whole toolkit down into 3 easy-to-understand buckets. Number 1, creational patterns. These handle object creation, making your code way more flexible and heavily reusable. Number 2, structural patterns. These show you exactly how to snap smaller objects and classes together into larger, super efficient structures, keeping everything organized. And number 3, behavioral patterns. These are all about communication, making sure your objects talk to each other cleanly and have strict, clear responsibilities without throwing errors everywhere.
And that brings us to our final thought for this explainer. Look at your own projects and ask yourself, are you building a massive interchange where a simple traffic light would do? As you take these blueprints and this shared language back to your own development team, really challenge yourself. Design patterns are undeniably powerful tools. They evolved from physical city planning to digital software architecture and have saved developers millions of hours. But you have to think critically about when, where, and why you use them. So use the blueprints to avoid chaos, but never ever lose sight of the value of simplicity. Thanks for joining me, and I hope this helps you build smarter, cleaner code.